Hi, everybody. Today we're going to look at U.8, which is solving a system of equations using substitution. This is probably the second best method for solving systems. And I'm going to skip around a little bit. I haven't previewed it, but we're going to use substitution to solve. We're looking for a pair, a point, an ordered pair that makes the first and second equations true. Now notice that they tell me what y is. So in order to find x, all I have to do is substitute for the y. So that's what I'm going to do. Instead of y, I'm going to put a 7. Sorry, I kind of covered it up there. That says y equals 7. Let me fix this. So I am going to substitute into the first equation 2x minus 7 times y equals -1. And what I'm going to do is instead, I do? It's -3. Jeez, I just made a mistake to start with. There we go. Instead of y, I'm going to put a 7. A lot of people make the mistake of putting something in addition. We are exchanging, we're putting 7 instead of y. It is a substitution. And we simplify, that's 2x minus 21 is equal to -1. We're going to add 21 to both sides. And I'm not going to write that, but you can write adding 21 to both sides and you get 20. And we're going to divide both sides by 2. And I'll go ahead and do the division. I like to write division using a division line. And when I divide 2 by 2, I do get 1x, which is just x equals 10. So my ordered pair is 10. But well, my x is 10. But what's my y? Well, I know what y is. It tells me right there. Y is 7. So there you go. And that's all you have to do, substitute. Now, it could be an expression, and that's where people get a little confused. So stick with me for a little bit. We're going to start with our equation, -4 times x plus y equals 7. And instead of x, I'm going to put a -2. And then I'm going to simplify. That's 8 plus y equals 7. And I'm going to subtract 8 from both sides, or add a -8, whatever makes more sense to you. And y is equal to -1. So I have -2 for x, because they told me that, and -1 for y. We're just substituting. Easy stuff, easy stuff. Now this one is a little more interesting. Now this one, I could substitute the first or the second y, and it doesn't matter. In other words, I have y equals 2x minus 4. And instead of this y, I'm going to put -x plus 8. Oh, geez. -x plus 8. Now, a good idea is to just get in the habit of always substituting inside parentheses. It'll lead to fewer errors in the future. So I know you don't need the parentheses in this case, and I am going to get rid of them. And the second thing I recommend is that instead of dealing with your numbers first, always try and get your variables together. By putting them together, don't think of it as moving the x across the equal sign. Some people learn what we call transformational algebra, and that's a pretty bad idea. What you want to do is you want to learn what's called property-based algebra. And in property-based algebra, I am going to add x to both sides. And I'm allowed to do this because of what's called the addition property of equality. That's what allows me to do this. And -x plus x is 0. I still have the 8, and that is equal to 3x. Be careful. 2 x's plus 1 more x, 2 boxes plus 1 more box makes 3 boxes. Oh, that's -4. I'm going to leave it like this. Now, of course, for most of you, two-step equations are pretty simple. You add 4 to both sides and divide by 3. So I'm going to add 4 to both sides. I'm not going to write this out. I add 4 to both sides, and then I divide by 3 on both sides. I'll go ahead and write the division. Now, a lot of people get confused because they say, well, wait a minute, the x is on the wrong side. It doesn't matter. 4 equals x is the same as x equals 4. That has a name. That's called the symmetric property of equality. If A equals B, then B equals A. So anyway, there it is. X equals 4, And the problem is, what's y? Well, you need to substitute into either one of these. It doesn't matter which equation you substitute into. If I substitute in x into this one, I get 8 minus 4, which is 4. That's what y is equal to. I could also substitute the 4 into the second equation, and I get negative 4 plus 8, which is also 4. So 4, 4 is my solution. X is 4 and y is 4. All right. Again, same type of substitution. I'm not going to write my parenthesis. In some ways, it's a good idea, but I'm just going to leave it off. I'm going to add x to both sides, and I'm going to have 2x. And I'm not going to do 2 steps in one. A lot of times, what I do is I subtract my 4 at the same step. I subtract 4 on both sides, and I get 2x equals 4. And then I divide by 2, and I get x equals 2. Notice I'm always doing whatever I do to one side, I have to do to the other. Those are the properties of equality. Putting 2 in for x, notice that y is equal to x plus 4. And putting this 2 in for this x gives me 6. And like usual, I am going to speed up as I go. So this is 2, 6. And hopefully it's going to be clear for you. Now this substitution, I'm just going to go ahead and substitute negative 6x plus 2 times 5, because remember y is 5, equals 16. I'm going to subtract 10 from both sides. Subtracting 10 gives me 6. Dividing by negative 6. A common mistake is to want to divide by 6. And that's a very common error. And here's why you don't want to do that. If I take a negative 6 and divide it by 6, I get negative 1x. That isn't what I want. I want to get x by itself, or 1x. So I have to divide by negative 6 on both sides so that I get positive 1 here. Anyway, I get negative 1 for x. If x is negative 1, of course my y is 5. It told me already. So hopefully that one's clear. Let's look at a better one. Again, one thing I want to point out is that it doesn't matter which direction you substitute on these. And here's what I mean. I can take this y value, because this is y, it says y equals this, and put it here. But I could also take this y value, and I could have put it here. And it makes no difference. Either way, if you have 2 things that are equal to each other, clearly they're equal. If 2 things are equal to the same thing, then they're equal to each other. If A equals B and A equals C, then clearly B equals C. Same type of reasoning. Anyway, negative 3x plus 8 is equal to 5x minus 8, however you want to get there. Now, what I'm going to do is I'm going to add 3x to both sides, which means that I'm going to have 8x over here. And I'm going to also add my 8 to both sides so that it's by itself, and I get 8x equals 16. I'm just doing 2 steps in one. I'm adding the 3x to both sides in my head, and I'm adding the 8. Now this takes a little bit of practice, because what you don't want to have is you don't want to end up with a variable and a number on one side equal to 0. Anyway, I have x equals 2, of course. And if x is equal to 2, I can substitute it into either equation and get my value for y, which also happens to be 2, because 10 minus 8 is 2. Hopefully that's clear. Same thing. I'm not going to go through that again. 4x plus 8 equals negative 2x minus 10. And again, I'm going to speed this up a little bit. So I'm going to add 2x to both sides, which gives me 6x. I'm going to subtract 8 from both sides, which gives me negative 18. And I'm going to divide by 6 on both sides. Now I did a bunch of things. I added the 2x to both sides. By the way, this is a really big error. I see a lot of students do the following, and they say to themselves, well, you know what I mean. I mean, I'm really adding 2x, but if you write this, I guarantee that later on, you're going to start adding things like these. So a good idea is if you mean plus 2x, you should write it. Now, I didn't write mine down because I've done it enough times to where 2x and 4x is 6x. I also subtracted the 8 from both sides. A lot of people go, oh man, negative 10 minus 8, that's so hard. Well, it's not. My rule for adding negatives is that debt accumulates. Think about it like this. If you owe $10 and you borrow another 8, clearly you owe 18. Dividing by 6 on both sides gives me negative 3. So I have negative 3 for x. Now I'm going to substitute the negative 3 in for the x. Now I do this in my head, but I want you to see it. This is what I'm doing in my head. I'm substituting the negative 3 in and multiplying it. And of course, when I add negative 12 plus 8, the rule is who won? The negatives win by 4. A lot of people are still grabbing their calculator to do basic integer operations. This should be able to be done instantaneously, and because it's not that hard. All you have to do is compare the two numbers, and who won is the negatives win by 4. So that's going to be negative 4 for my y value. And you could substitute it into the top equation and see that it does give you 6 minus 10, which is negative 4. Okay. Another substitution. X minus 4 is equal to 3x plus 8. I'm going to subtract the x on both sides, which gives me the 2x. And because I have the 2x on the right over here, I want to get rid of that 8. So I'm going to subtract 8 from both sides, which gives me negative 12. And then I'm going to divide by 2, and I'm going to get x equals negative 6. Now, a lot of people are going to say, well, a calculator just makes your life so much easier. It doesn't. It makes it harder because you're constantly having to push the buttons when you could just simply do it in your head. This really is that easy. Now I'm going to put the negative 6 in for x, and I get negative 10. Negative 6 minus 4 is negative 10. If you want to check your answer, you could put it in the top equation, which is negative 18 plus 8, which is also negative 10. So we have negative 6 and negative 10 for y. Sorry, I should have made that clear. All right, substituting in, negative 5x minus 9 equals negative 3x minus 7. We're doing substitution. Getting rid of the negatives is always nice. There really is no way to do it in this particular case. Some people like always getting their x's on the left, which is fine. It doesn't make any difference. So I could add 3x to both sides, or I could add 5x to both sides. I am going to go ahead and add 3x to both sides in my head. Now, adding 3x gives me negative 2x, but I want it by itself, so I have to add the 9 to both sides, which gives me 2. Dividing by negative 2 on both sides gives me x equals negative 1. And I can substitute the negative 1 in and get 4. Sorry, negative 4. Don't want to make a sign here. Y is equal to negative 5 times x minus 9. That negative 1 makes 5 minus 9, which is negative 4. So we're talking about negative 1, negative 4. Okay. This one is much more interesting. Now, this is actually set up in what we call standard form. Both of these equations are in standard form, and the easiest method is the addition method. But I'm going to go ahead and do it using substitution because that's the way they want me to do it. Now, later on, of course, you would probably want to use addition method for this. But I'm going to go ahead and solve the first equation for y. So I have minus 5x plus y equals negative 10. And in order to solve for y, you have to get it by itself. So I have to add 5x to both sides. That means that y equals 5x minus 10. Now I'm far from done. I still need to substitute this y value into the other equation. If you substitute this y value into your first equation, you're just going to get something like 0 equals 0 or negative 10 equals negative 10. What we want to do is substitute this equation, which is the first one, into the second one. So I have negative 9x plus 9 times y equals 18. And I like to write it with a parenthesis instead of a variable, so that instead of this y value, I can put that 5x minus 10. Now I have to distribute this 9. Be very careful. If this were a negative, I would have to distribute negative 9. And that is a big common error that happens in math. So I have negative 9x plus, this is just a plus, 9 times 5x is plus 45x. Now you might have noticed that I wrote those arrows on top. You cannot imagine how many times I've seen students and myself say to yourself, oh, I'm going to distribute the 9 to both parts. You multiply the 9 times the first part, and then you forget and write minus 10. Of course, it's not minus 10. It is minus 90, isn't it? Now I have to add these two together. Oh my goodness, we have to do some math. Well, 45x minus 9x is 36x. Minus 90 equals 18. So I know I'm going to add the 90 to both sides. So I'm just going to go ahead and do that now. Adding 90 gives me 108. And what's so nice is that 36 goes evenly into 108 3 times. So x is equal to 3. Now we're almost done. All we have to do is substitute our x into any equation we want. I happen to like this equation because y equals. So y equals 5 times 3 minus 10. Because I know x is 3, then y is equal to 5 times 3 minus 10, which is 15 minus 10, or 5. So we're talking about 3, 5. Now, before I finalize this, I just want to show you something. You can, if you're willing to do the work, in just a few seconds, you can check your answer. You see, in that second equation, I can take 3 times negative 9 and get negative 27 and 45 and see if I get 18. Well, this is the same as 45 minus 27. 7 from 15 is 8, and 2 from 3 is 1. 18, sure enough. Okay, hopefully it's all good. All right, we're going to do the same thing again. I'm going to get y equals 9x minus 9. All I did was add the 9x to both sides. I'm going to substitute into the second equation. It's the same process, but there's that negative that's going to mess you up. I know you don't believe me, but you cannot imagine how many times people distribute a positive 3 to both parts and get it wrong and just leave the negative where it is. Now, here's one way of thinking about why this works. Remember, well, for those of you who have seen some of my other videos, you know that I hate subtraction. And there's a really good reason why subtraction is a bad idea. In this particular case, this equation is the same as plus a negative. Now is it clear that the negative 3 has to be distributed? So I have 9x plus negative 27x plus 27 is equal to negative 9. Now I need to add these two together, which gives me negative 18x. I'm going to subtract the 27 from both sides. That's going to give me negative 36. And when I divide by negative 18, I'm going to get x equals positive 2. And I'm almost done. I know it seems long, but it really isn't that bad. I'm going to substitute my 2 in for this x, and I'll bet you can do it in your head. 18 minus 9 is 9. So I have 2 and 9. Now my final step is to say, well, wait a minute. I used the first equation, so I know the first equation is 2, 9. But what about the second equation? If I put 2 in for this second equation, I get 18. I just took the 9 times 2 right there. And then I take minus 3 times 9. And do I get negative 9? I do. That is absolutely sure to be the right answer. Okay, guys, I hope you're getting good at this. We're going to do a substitution. 2x minus 1 equals 3x plus 3. In this particular case, I don't like a negative x. So what I'm going to do is I'm going to subtract 2x from both sides. I know a lot of people, like I said, like to get their x's always on the left. But in this particular instance, I think it's easier to understand if I do this. And I want to caution you to not do this. This is a very common kind of thing. I see students do this all the time. Really bad idea. I know what you mean, you know what you mean, but if you were to do this over and over again, eventually you'll start saying that something like this is, 1x or something. It's a really bad idea. This, much better. Anyway, there it is. Negative 1 equals x plus 3. We're almost done. We subtract 3 from both sides, and we get x equals negative 4. Or, x equals negative 4. We have to substitute the x in and get our y value. And it doesn't matter which one you put it in. I'll put it in the first one. That is negative 8 minus 1 is negative 9. And we're almost done. We have a negative 4 and a negative 9. Now, as a final check, I'm going to put my negative 4 into the second equation, which gives me negative 12 plus 3, which is negative 9. So, looks good. Come on. All right. Substitution again. X plus 5 equals negative 2x minus 7. I'm going to add the 2x to both sides, which gives me 3x. I'm going to subtract the 5 from both sides, which gives me negative 12. Again, very important that you know how to work with integers. Divide by 3 on both sides, and you get negative 4. There's my negative 4. And adding 5 to that gives me 1. Now, I can put that negative 4 into the second equation, and it should give me 1. And 8 minus 7 is 1. I know I'm speeding up a little bit. Hopefully it's not too fast. Again, this is literally 2 equations that are in what we call standard form. And addition method is by far and away the easier way to go. And you're going to love addition method. For those of you who feel like it, that's going to be the next section I do. I'm going to do addition method next. So please check it out. You will love addition method compared to substitution. So I'm going to go ahead and solve the first equation for x. And I think you can see why I chose to solve for x, hopefully. If I solved for y, I would end up doing 2 steps. I'd have to subtract the x and then change all the signs. If I solve for x, I just have to add y to both sides. So, and I'm just going to say x equals y minus 20. All I did was add y to both sides. And y plus negative 20 is the same as y minus 20. Now I'm going to substitute this into my second equation right here. This says, my screen is slippery, so if I make a little error, it really messes it up. Hopefully this is clear what I did. What I did was I rewrote this second equation with parentheses instead of an x. And I'm going to put the y minus 20 in there. I do have to distribute this negative 10 to both parts. Negative 10 times negative 20 is 200. Oh my goodness, we've got this, and I want to show you an error. This is wrong, 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 but I want to show it because it's a very common mistake. Students do this a lot. You see how this sort of looks like you've got y's on both sides? You kind of do. I have y's on both sides of this 200, and this is a mistake. This is wrong, 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 wrong. Do not do this. And here's what I did. Uh, you cannot imagine how often I see this happen. Negative 8y plus 8y is 0, and negative 10y plus 8y is negative 2y. However, notice that I added 16y to the left of my equation and added nothing to the right. This is absolutely incorrect. These y's are on the same side of the equation, and they have to be added together. A lot of people go, wait a minute, that's subtraction. That's why I don't like subtraction, because subtraction does not allow you to move things around and add and out of order. But addition allows you to do that. You see, if I change it to this, now I can add the negative 8y with the negative 10y. So I hope you won't make that mistake. I wanted to bring it up. And I know more than you bargained for, but you always have the option of fast forwarding, which is fantastic, or just skipping it completely. Don't have a tape anymore. Negative 18y, dating myself, plus 200 is equal to 20. Subtracting the 200 from both sides gives me negative 18y equals negative 180. And dividing by negative 18 gives me y equal to 10. Isn't that pretty? Now I'm almost done. I can now substitute the 10 right there, can't I? And that gives me x equals negative 10. So my solution is going to be negative 10, 10. Now I know that's going to work in my first equation because I used my first equation to get it. So I'm going to check my second equation. Well, negative 10 times negative 10 is 100, and 10 times negative 8 is negative 80, and that does give me 20. See it right there? I hope it's clear and that you see that that last just 10 seconds worth of effort is well worth it. Substitute it in and make sure you got the right answer, okay? All right. Oh, I want to do addition method so badly here. We're going to go ahead and subtract x from both sides. I'm going to go ahead and solve for y. So I have y equals negative x plus 2. All I did was add a negative x to this equation up here. Now I'm going to substitute the negative x plus 2 into my second equation for y. Instead of y, see the second equation? I'm going to write parentheses instead of y. I'm going to put the negative x plus 2 in there. I'm going to distribute the 4 to both parts, and I get 7x minus 4x plus 8 equals 5. Now I'm going to do two things at once. And I know it seems really difficult at first, but it's really good practice. This is going to give me my 3x. That's the same as that, isn't it? And I'm going to subtract the 8 from both sides, which gives me negative 3, and x is equal to negative 1. And we're almost done. Be careful, it's easy to make an error in this particular case because I'm talking about negative x. And a lot of people, when they substitute that negative 1, guaranteed, are going to want to put that just a negative in front of it and say that y is equal to 1. So let me show you an error. This happens all the time. Students will write this. This is wrong, by the way. Do you see that I have a negative in front of this x right here? Well, that says literally the opposite of x. Well, that's not the opposite of x right here. This is x. So be careful. This is incorrect. Now it's correct. And we have 1 plus 2, which is 3. Very easy to make a mistake. So x is negative 1 and y is 3. Now, how can I check that? Well, I can put it in the top equation. Negative 1 plus 3 is 2, duh. And into the second equation. 7 times negative 1 is negative 7. And 3 times 4 is 12. And that does give me 5. And there's my answer. I know it's right. Be careful. And we're getting there. We're getting there. Thanks for hanging with me. Oh, if only we could do addition. Okay, so I'm going to solve for y. Y equals negative 2x plus negative 8, or just minus 8. It doesn't matter whether you write the negative 2x plus negative 8 or negative 2x minus 8. It is the same thing. And you want to go back and forth and back and forth and back and forth because sometimes one is better than the other. So you want to be able to use whichever one makes more sense. And we substitute because they're insisting, they want us to do substitution. It is really easy to make mistakes because you see all those 8s? You can get one confused with another and make mistakes because of it. So be careful. We have negative 8x plus negative 16x plus negative or minus 64. You see that 8 times 8 is 64 instead of 16? Can you see why people might put 16 there? Because there's a 16 over here too. It's just an easy mistake to make. Now I'm going to add these two together. That's negative 24x. I'm going to add the 64 to both sides. I'll write it down for you. It's going to give me 48, isn't it? Sorry, I should have written it further over. Anyway, I'm going to divide by negative 24, and I get negative 2 for x. And I need to substitute the negative 2 in. Now I've got negatives all over the place, and that can give you trouble. But the y is going to be negative 4. If I do y equals negative 2 times x minus 8, hopefully you can see that if I put a negative 2 in there, I'm going to have 4 minus 8, which is negative 4. So negative 2, negative 4. Now let's test it in the second equation. Notice the first equation. You can do the first equation too. It's not that hard. 2 times negative 2. Negative 4 plus negative 4 is negative 8. There, done. Now I'm going to put it in the second one. Negative 2 times negative 8 is 16 plus negative 32 does give me negative 16, doesn't it? There it is. It's true for both. We know it's right. It's worth that little bit of extra effort, I promise. All right, I'm going to solve for x. And the reason I'm going to do that is just to save myself some work. So I have x equals y plus 18. You'll notice I also switched, instead of putting 18 plus y, I put y plus 18. I have 7 times x plus 5y equals 6. And we're going to substitute that x right there. So I have 7 times y plus 18 plus 5y equals 6. We're going to distribute that 7 to both parts. That's 7y plus 7 times 18 is 126. 7 times 8 is 56. And 70 makes 126, doesn't it? And I'm going to do two things at once. Again, I'm not going to subtract 5y, am I? No, no, no. I am going to put the 5y with the 7y. They go together. They're on the same side. We add like terms together on the same side. So I have 12y on this side. I'm going to go ahead and subtract the 126 in my head on both sides, which gives me negative 120. All I did is subtract 126 on both sides, and now I'm going to divide by 12 and get my negative 10. Now I'm almost done. I just have to put my negative 10 in and get my x is equal to 8. So 8, negative 10. And now that I have my answer, it's really easy to check it. 8 minus negative 10 is 18. I have a double negative there. And 7 times 8 is 56. Oh, I said 56. I was going to write 5x. 56, that's my first part, plus 5 times negative 10 is negative 50. And that does give me 6, doesn't it? There it is. It really doesn't take long, and you can check your answer. All right. Oh, no. Oh, my kingdom for addition. Okay. Am I going to solve? I'm going to solve the second one for y. I have a reason for doing it. It's kind of strange. You do not want to do it this way, I promise. But I'm going to do it because it says we want to solve using substitution. I would use addition on this, but I'm going to go ahead and solve the second equation for y. So I'm going to get 5y equals negative 4x minus 10. And I'm going to divide by 5. Now be careful. I have to divide this term by 5, and I also have to divide that term by 5. A very, very common mistake in this particular solving is to do this. And I'm going to show you the mistake now. This happens all the time. Wouldn't you be tempted to do this? And it's wrong. You're going to get the wrong answer. So be careful. This 5 under here is a common denominator. And the way to avoid that problem is to divide all the terms by 5. I've probably told you this before, and I'm sure you've seen it on my other videos, but I just wanted to make sure since I had the chance to teach again. So there it is. Y equals negative 4/5. If you want to use 0.8, that's fine. It doesn't matter. It's the same thing. Minus 2. All right, there we go. Now we're going to substitute this into the first equation, aren't we? Because notice that I chose the second equation to solve. So I'm going to substitute this into the first equation, which gives me negative 9x minus 10 times y, which is negative 4/5 x minus 2 equals 10. Now, I had a very good reason for solving the second equation. I need to distribute the negative 10 to both parts. Notice that that negative is on the 10. And that gives me negative 9x. A negative 10 distributed in here gives you 40 over 5, or 8x. Negative 10 times negative 2 is plus 20 equals 10. And we're so close now. I have negative x. When I add these together, I subtract 20 from both sides, and I get negative 10. And I'm almost done. X is equal to 10. Now I just have to put this 10 into here and get my y value. So lots of substituting, huh? Y equals negative 4 times 10 over 5 minus 2. And this is going to be negative 8. Which gives me negative 10. So it looks like I've got 10, negative 10. Now, is there a way to check that? Well, sure. Take a look how fast this goes. 40 minus 50 is negative 10. Done. Now watch the first equation. Negative 90 plus 100 is 10. Done. I just tested it in literally 2 seconds. I spend 5 to 10 minutes working out the problem, and then I don't take the time to check my answer. You should always check your answer. Looks like we might have one or two more. Maybe 2 more. Darn it. All right. So I'm going to solve this first equation. In this particular case, I'm going to go ahead and solve it for y. Oh my goodness. My disk is almost full. I'm going to have to take some of this stuff out. Wow. Okay. I'm going to solve the first equation for y, and y is equal to 2x minus 12. And then I'm going to substitute that y into the second equation. I'm going to distribute that negative 5 to both parts. That's negative 10x minus 10x plus 60 equals 20. I have negative 20x equals negative 40. I just subtracted 60 from both sides. Then I'm going to divide by negative 20, and I'm going to get x equal to 2. I'm almost done. I still have to substitute the 2 in here and get -8, don't I? 4 minus 12 is -8. So we have 2, -8. Now, here, right now, test your answer. It goes very quickly, I promise. Watch how fast this goes. Now, I do this in my head, but I'm going to write it down for you. 2 times 2 is 4 minus -8, and that is 12, isn't it? That's the first equation, and it's good. Now I'm going to put it in the second equation. 2 times -10 is -20. -8 times -5 is 40. And I'm actually going to add these without looking up. Don't look up. 20, that's true. And yes, it absolutely works. It's a really good idea. And this might be my last one, but I might have one more. Yeah, they gave me a last one. All right. No. I am not going to do it. I am going to do addition method. Now, addition method involves, no, I'm not actually. I'll do addition method when I do the next one. I'll go ahead and solve it. Dang it. Not sure which one I want to solve. It doesn't really matter. I'll solve the second one for y. So I have 5y equals 9 minus 3x. Divide everything by 5. 9 over 5 minus 3/5 x. I just divided everything by 5. Now I need to substitute this into the second equation. Into the first equation. -8x minus 6 times y equals 20. And we have 9 over 5 minus 3 over 5x. And I have to distribute the -6 to both parts. That's going to be minus 54 over 5. 6 times -3/5 is positive 18 over 5x. And that's all equal to 20. Oh, man. Okay. So in order to solve this equation, I could write decimals. I could mess with it for a long time. But I want to point something out. Anytime you have fractions and you don't like fractions, you do not have to deal with them. All you have to do is multiply the entire equation by 5. Now, what I'm going to do is I'm going to multiply this side of this equation by 5, and I'm going to multiply this side of this equation by 5. This 5 over here gets distributed to all 3 terms. I'm going to get, and I'm going to have to write it at the top of my page because I'm kind of running out of space. So I'm going to write it at the top, okay? I have 5 times -8x is -40x. 5 times -54 over 5 is just -54. The whole point to multiplying by the 5 was to get rid of this 5. Minus 54. Multiplying the 5 times the last part gives me 18x. And it's equal to 100. That's the 100 over there. Now be careful. I'm adding these together. That gives me -24x. And I also have to add the 54 to both sides. So I get adding the 18 to the -22 gives me -22x. Excuse me. Now I'm going to divide by -22 on both sides. Seeing if I made any weird errors here. I don't see any. And I believe that gives you x is equal to -7, isn't it? So I'm almost done. If x is -7, I can solve for y, and I need to find my y value. Now my y value is, I'm going to go ahead and use this. It doesn't matter which equation you use. I'm going to use the first one. So I have the second one. That way I don't have any negatives in it. -7 plus 5y equals 9. I'm going to add 21 to both sides. and I get 5y equals 30, and y is equal to 6. Now, I did a lot of work. I did a lot of stuff. I know some of it may have lost you somewhere along the way. I hope not. I hope that this has convinced you that addition method is the way to go. The x is -7, and the y is 6. And now I'm going to do one final thing. I am going to test it by putting those two numbers into my first equation. And I am doing this. I'm going to get rid of something here. Let me get rid of something real quick here. I'm just going to get rid of this for a second. Hopefully you got it. Of course, you can always go back and watch it slower. I can't imagine that anybody's watching at this point, but -8 times x, which is -7. And we have -6 times y, which is supposed to be 6. And I'm actually going to do this problem. This is +56. And this is -36. And when I subtract these two, I do get 56 minus 36 is 20. And I can see that my first equation is true. If I want to test the second one, it's just -21 plus 30, which is 9, isn't it? It's a little ugly there. There we go. Can't seem to get it to join. There we go. And sure enough, it's true. So it looks like we're done. We have our mastery, and I hope you guys will do it too. And I will see you back. And I'm going to do substitution, so come see me. Bye-bye. So addition method.